Welcome in Dark Core. If you watched our videos about exoplanets, you must already know that scientists are looking for oceans in the Goldilocks or habitable zone, tens to hundreds of light years away from Earth. But it's difficult to imagine that a planet more than 5 billion kilometers away from its star can have an ocean of liquid water on it. And it's even harder to believe that there could be life on such a planet. However, recent findings prove it's possible. And there's just such a world in our solar system, Pluto. INTRO, according to astronomers' estimates, Pluto is just about 2,370 kilometers, 1,470 miles, in diameter, which makes it smaller than a number of solar system moons such as Ganymede, Titan, Callisto, Io, the Moon, Europa, and Triton. And this made scientists wonder if Pluto could still be considered a planet. To compare, it's almost 60 times smaller than Jupiter, diameter 143,000 kilometers, 88,850 miles. So scientists were skeptical about Pluto's status as a planet. The small world was rather just a part of the population of small icy bodies beyond the orbit of Neptune or the region known as the Kuiper Belt. But it wasn't until 1992 that astronomers discovered its first resident. The space object dubbed 1992 QB1 was found using a 2.24-meter, 7.34 feet, telescope located on Mauna Kea, the island of Hawaii. The discovery of this celestial body further intensified discussions on the status of Pluto. 8 years later, the New York Hayden Planetarium presented a scandalous exhibition that featured just 8 planets. Then, scientists discovered more Kuiper Belt objects with a mass roughly that of Pluto, such as Quaoar, Sedna, and Eris. And the newly discovered Eris turned out to be even larger than Pluto. First, this Kuiper Belt object was even called the 10th planet of the solar system. Eventually, the International Astronomical Union, IAU, created a committee to establish a general definition of a planet. One idea was to extend the list of solar system planets from 9 to 12. It was proposed that Pluto along with its satellite should be considered twin planets, and Ceres and Eris had to join a planetary list as well. But the idea was criticized and rejected. Eventually, a new definition of a planet was created. On the last day of the meeting, August 24, members of the IAU defined criteria for a celestial body to be called a planet. So what are these criteria? To be a planet, a space object must be in orbit around the Sun, it must have sufficient mass and gravity to force it into a spherical shape, and it must also be able to clear away any other objects of similar size near its orbit. And there are just 8 such planets in our solar system, starting with Mercury and ending with Neptune. So because Pluto only meets the first 2 criteria, it was reclassified as a dwarf planet or planetoid. It all started when the New Horizons approached the dwarf planet located almost at the edge of the solar system. Scientists have long been interested in Pluto. Even such an advanced device as the Hubble Space Telescope could only see a few bright spots on this planet. And the most thrilling part about Pluto was its location, the Kuiper Belt. This region of space consists of a bunch of icy bodies of various sizes. Scientists think these are the remnants of the solar system building blocks. So, studying Pluto could help us better understand how our solar system and our home planet were formed. And in 2003, scientists were able to convince NASA to organize an expedition to Pluto. 3 years later, the New Horizons probe atop the Atlas V carrier rocket was launched from the U.S. Space Force Station at Cape Canaveral. But just days before approaching Pluto, the spacecraft stopped communicating with Earth and scientists had to urgently reboot its software. Then the probe faced even more issues when it approached Pluto. Despite its small size, the dwarf planet has 5 satellites, the largest of which is roughly half the planet's size, diameter 1,212 kilometers, 753 miles. But astronomers were worried that the planetoid could be also surrounded by swarms of tiny satellites that could form rings, like those around Saturn or Jupiter but much smaller. A collision with such a satellite or even a dust particle the size of a grain, at a speed of almost 16 kilometers per second, 9.9 meters per second, would mean a disaster for the mission. It would cause the energy of a collision equal to a large caliber gun projectile and blow the probe to pieces. But everything worked out well, and mankind was finally able to see the first photos of the dwarf planet. As project manager Professor Alan Stern stated, it exceeded my wildest expectations in every way. I am delighted. The Pluto system is simply stunning. Another participant of the project, Professor Hal Weaver, said, "Our jaws just dropped. That was incredible. Who would have thought that a cosmic body that receives just 1/1600 of sunlight compared to Earth and is 3 billion miles away from the Sun can be so beautiful?" Interestingly, Pluto, among all other cosmic bodies in our solar system, is most similar to Earth. Scientists were shocked to see frozen icy lakes, icy mountains the size of the Rocky Mountains, and chasms larger than the Grand Canyon. And all that is on a planet smaller than the Moon. What's more, like Earth, Pluto also has a blue atmosphere. But, unfortunately, there's no oxygen in the atmosphere of the dwarf planet. Just nitrogen and numerous deposits of methane and carbon monoxide. The pressure there is about 1 pascal, which is about 100,000 times less than that on our planet. The average surface temperature is -226 to -240 degrees Celsius, -375-400 degree F. Scientists were also intrigued by Pluto's smooth surface, almost round in shape, occupying about a third of the entire area of the planet. Its diameter is 1,492 kilometers, 927 miles. The area named Sputnik Planitia has practically no craters on it, meaning there are no traces of meteorite impact. Scientists believe it was formed relatively recently, during the last 100 million years or so. Further analysis showed that this is a large basin filled with frozen nitrogen. But for now, let's take a look at Pluto's main satellite. Charon is located at a distance of about 19,600 kilometers, 12,180 miles, from the surface of Pluto, while the distance between the Earth and the Moon is roughly 385,000 kilometers, 240,000 miles. This means that the tidal forces between the dwarf planet and its satellite are very powerful. And according to the laws of celestial mechanics, under such conditions, the rotation of a satellite becomes synchronized in time, meaning the period of its revolution around its axis and a planet becomes the same. That is, Charon is always facing Pluto on one side. Now, let's get back to Sputnik Planitia. This area is located on the axis connecting the centers of Pluto and Charon, and the probability that such a large geological formation lies on this axis by chance is about 5%. Most likely, sometime in the past, a pole shift occurred on Pluto and Sputnik Planitia took the place of one of the poles. But for this to be possible, this region should have had a positive gravitational anomaly. In other words, it must be heavier than the average volume of Pluto. But Sputnik Planitia is a hollow basin filled with light ice, frozen nitrogen. And this made scientists think that there may be a denser substance under its surface that adds mass to the area. So what is this substance? Scientists got interested in the deep cracks that are clearly visible on the surface of Sputnik Planitia. These cracks usually form as the planet's surface expands. And as the temperatures on the surface of Pluto are freezing, there must be a substance beneath the frozen nitrogen crust that expands when it cools down. So what kind of substance can expand rather than contract when it gets cooled? Water. So, does this mean that there's an ocean of liquid water hiding underneath a layer of frozen nitrogen in this giant basin? That's what scientists thought and later confirmed by another observation. Geologists studied three-dimensional maps of the surface of Pluto and identified two quite unusual objects, mountains up to 5 or 6 kilometers, 3.1, 3.7 mi high. But these aren't just mountains. Scientists have also found a billion-year-old volcanic craters and textures resembling traces of ancient eruptions on their surface. The two gigantic volcanoes were named Wright Mons and Pickard Mons. If scientists are right that these geological formations are volcanoes, Wright Mons and Pickard Mons are the first large cryovolcanoes discovered in the solar system. But, so far, scientists aren't 100% certain about the nature of these objects. They definitely look suspicious, so we're looking at them closely, says Jeff Moore, a member of the mission science team. But these volcanoes are on the outskirts of Sputnik Planitia. So it's very likely that this is the case. Perhaps in the past, Pluto had two cryovolcanoes that erupted with icy water instead of lava. As for Sputnik Planitia, scientists think that it was formed as a result of a cosmic catastrophe, a large celestial body once fell on Pluto, resulting in a crater with an initial depth of about 7 kilometers, 4.3 miles. The collision caused a significant decrease in the thickness of the dwarf planet's icy surface and also made water from the subsurface ocean rise. Geologists have also considered yet another idea. Pluto could have no subsurface ocean at all. In this case, for a positive gravitational anomaly to occur, huge amounts of nitrogen ice must accumulate in the impact crater. An amount that big wouldn't simply fit into the crater. Scientists say that the depth of the ocean on Pluto should reach 100 kilometers and that it has existed for billions of years. Large quantities of ammonia and methanol could help maintain the subsurface ocean in a semi-liquid state. Scientists are almost certain that the subsurface ocean isn't completely frozen. Because if it were, Pluto's low temperatures and high pressure inside the planetoid would make water ice turn into denser cubic or ice too. This would have been accompanied by a decrease in the volume of ice and compression of Pluto's icy crust, but the images taken by the New Horizons show a different picture. This means that the ocean may still be partly liquid. Something similar even happens here on Earth. Our planet does also have a region with very low temperatures and there's a reservoir with liquid water under its surface. This is the famous Lake Vostok with a maximum depth of 1,200 meters, 3,900 feet, and an area of 15,790 square kilometers, 6,096 square miles. But how did Pluto, despite its great distance from the Sun, get enough heat to create a liquid ocean that survived under the icy crust up to this day? Scientists believe two potential sources made it possible. The first one is the heat released during the decay of radioactive elements inside the dwarf planet. And the second one is the gravitational energy release resulting from the bombardment of Pluto's surface. Calculations show that if all gravitational energy was stored as heat, this source alone would be enough to create a liquid ocean. However, for this to happen, the accretion process must be very fast. Otherwise, a planetary body's surface would give off a significant part of the energy back into space. Researchers calculated that to heat up so quickly, Pluto must have formed in about 30,000 years. Scientists suggest that some other large Kuiper belt objects, such as the dwarf planets Eris and Makemake, also had a hot start and had liquid oceans at the very beginning of their existence. So far, it seems humanity only looks for water millions of light years away while it has always been much closer, in our solar system. And water often means life. So there's a high probability that life could one day be found in the depths of Pluto. Even on our planet, there are life forms that can survive without heat from the sun. Some bacteria live in thermal springs and survive because of the heat incoming from hot water. In science, there's even the concept of extremophiles or organisms capable of living and reproducing in extreme environmental conditions, such as very high or low temperature, pressure, acidity, oxygen, and so on. So why wouldn't there be life in Pluto's underground ocean? The great English science fiction writer Arthur C. Clarke predicted life in the subsurface ocean on Jupiter's satellite Europa in his famous novel, 2001, A Space Odyssey. This celestial body is larger than Pluto, and it receives more heat from the sun. So even though this is just a prediction, the same author was already right with yet another forecast. During the New Horizons mission, the probe's flight path was calculated according to the method described by the great science fiction writer in his novel. The idea is to use Jupiter's gravitational field as an additional source of acceleration to save fuel. According to the creators of the New Horizons project, such a maneuver allowed the device to arrive at Pluto 3 years earlier. To scientists' surprise, the dwarf planet turned out to be similar to our home. Like Earth, Pluto has a blue halo of atmosphere around it. Although a subsurface one, it also has an ocean, and the existence of certain life forms there is very likely. So the debate about whether Pluto should have a status of a planet is back on the table. Because it seems like the planet deserves it. But it also deserves another mission. We have to land on Sputnik Planitia, get to liquid water and finally put an end to the question of whether life is present there or not. This could be the greatest discovery since the beginning of the third millennium. But for now, like this video if you enjoyed it and don't forget to subscribe to our channel as there will be a lot more content about the mysteries of the universe. Thanks for watching Dark Core.